the next M in productivity that we are going to discuss today is the material, and the important concept that we want to cover is the type of measure for the loose material. Here, types of measure for material. So material we can measure, for example, in terms of the unit of volume, cubic feet, cubic yard, etc. But in this case, for the loose material, we have three type of measure that I'm going to talk in here. The first one is bank, cubic yard, and that is BCY. So it's the material at the natural condition, just like a soil at the current condition on the ground, that we call bank. Then when you disturb that material, it become loose. So we have loose cubic yard. And that is LCY. And the last one is you transport that loose material to the site, compact it, and that become a compacted cubic yard. And CY. So those are the three type of measure for the loose material, such as soil, sand, rock, etc. that we need to have, because the with the same material, but the volume will be changing, so that we need to know in order to estimate the cost properly. So what do I mean in here for this one? As you can see for the slide that you have, slide number 3 in this lesson. So the time of measure. So what is the at the natural condition, the volume, for example, 1 cubic yard, you see on the left side of the natural condition in place, so that we got BCY 1, and then we disturb with the excavator, etc., put it on the dump truck, the volume increasing, and that we call it loose cubic yard. So 1.25, it means it increasing 25% of the volume. The weight may be the same, but the volume increasing. And then we transport that to the site, compact it, it become only 0.9 cubic yard. So it's shrinkage from 1 cubic yard go to 0.9 cubic yards. That what is 25%, reduce 10%. That depends on the nature of the material and the way that we compact it. But basically that the process will be. And for that illustration, with the different material that you can have here, for the change for different type of soil, clay, common earth, rock, and sand and gravel. And for those of you learn in construction method and management, we also talking about this, because that important concept to deal with that class as well. This one is more with the estimating the cost. So as you can see, the unit weight for with the same material, but it at different condition, loose, bank, and compacted are not the same. The loose, the same weight, but the volume it increased. That's why the unit weight smaller. 20, for example, clay 2310 pound per cubic yard. For the bank, the natural condition 3000, and for the compacted it 3550 pound per cubic yard, and in parentheses that unit is kilogram per cubic meter. And it measured by percent swell change from the natural condition to the loose, and then shrinkage percent from the original condition, the bank, to the compacted. And now the next step, I want to show you how to get the percent swell, load factor, shrinkage factor, and shrinkage percentage in here. So let me put some symbolic to demonstrate the concept of bank cubic yard, loose cubic yard, etc. So at the beginning, if we have 1 cubic yard, at the bank condition, and that is we have the volume at this one is obvious, 1 BCY, and the weight, for example, 2000 pound. Okay, and if we disturb that material, it become increasing the volume, but the weight remain unchanged, so that we still have the weight equal to, in this case, still 2000. Of course, in the real life it may change because the water vapor, but it's not that much different. And the volume, for example, it becomes 1.25, and in this case LCY. You can see that. And then if you go to compact it, put in the as-built plate, it will be reduce the volume. And the volume, it may become only 0.9 that I show you in the previous slide. So V equal to 0.9. And it depends on the material for sure that we are talking about. Common earth, clay, sand, etc. The yields, the weights may be the same. Why I say maybe it's not exactly the same, because during the transportation, the water evaporate. When you compact, you may need add water more, so the weight can change. So that is the process of half. And from here, from the natural condition to the loose, that we have swell, right? Swell percent. So here, swell, because the volume increase. And from the natural condition to the compacted condition, that we call shrinkage. And the question is, how can we determine the relationship between the measurement in here? So how can we determine the measurement? So let's talking about the relationship of this measure. Of the three measures here. So there are two scenarios. If we want the loose volume and the bank volume, what is the relationship between the two? That is the first we want to investigate. Loose volume and bank volume. Loose volume and bank volume. So loose already disturbed, and bank the natural condition, and it measured by percent swell. So you have the equation is swell in percent, that is equal to 1 over load factor minus 1 minus 1 times 100. And then what is the load factor? Basically the load factor equal to loose density, and you use the table on the slide, and it's available in the exam reference, exam 1 reference, divided by the bank density. And that I show you in the slide with the table, the loose density tend to be less than the bank density. The load factor for all material tend to be less than 1. So that is loose and bank volume. The next we want to investigate is the relationship between the compacted volume and bank volume. Volume and bank volume. So we have the same equation. I have the shrinkage percentage measured by shrinkage, as you can see on the graphic. In percent, it equal to 1 minus shrinkage factor, 1 minus shrinkage factor. And then we have the, what is the shrinkage factor? Similar to there, we have shrinkage factor and equal to the bank density over compacted density. And except the rock, the bank density tend to be less than compacted density, so the shrinkage factor tends to be less than 1. But for the rock, after you disturb the rock, blasted it, regardless of how good we compact the material, the volume will not be as much as the original volume of the rock. So that reason, the shrinkage factor for the rock it tend to be greater than 1. We will go back to that table to show you later on. Just let's apply this into the problem 3 in here so that we can see a big picture of this relationship of those 3 measures. That problem 3 here, an engineer estimate that CE getting 33 cubic yard bank of clay in the ground for her scraper. This is one kind of equipment. The maximum load and the volume capacity of the scraper are 65,000 pounds and 30 cubic yard respectively. And the question asks, is the engineer load estimate correct? So she want to get 23 cubic yard of bank clay for her scraper, while the maximum load and volume for the scraper is 65,000 pounds and 30 cubic yard. Whether we can the scraper can carry 23 cubic yard bank cubic yard of the clay. That is the question. So for this problem, basically think about the elevator, right? I know this year virtual you don't have a chance to use the elevator if you don't go to our campus, but think about the elevator of Holmes Hall. So in the capacity of the elevator, they limit how many pounds you can carry and how many people. So there are two loads that we need to consider. How many people maximum they can get into the elevator with the social distancing, the capacity will be going down. It also the load, how many pounds, so that you can see 2 dimensions. In here, same for scraper, we also have 2 dimensions. The first one is the weight limit, 65,000 pounds. The volume limit, 30 cubic yards. And as you can see, that should be loose cubic yard because it already disturbed and put in the scraper. So from that, how can we solve this problem with the concept of 3 measures for the material we're talking about up there? So with that, we can see we determine the loose cubic yard of the 23 with 23 bank cubic yard here. How many loose cubic yard we can get after disturb this material? So loose cubic yard of the material. And as you can see here, it become a original BCY, bang cubic yard, time 1 plus 12%. Okay, so that's what we need to find out the loose cubic yard. And this is for clay. So we go back to the table, and for clay we have the square percent with the 30%, and you can see what does that mean. If we disturb this clay, the material will be increasing from the bank to the loose 30%. So from that we can have here equal to 23 BCY for the material that the engineer want to carry for the scraper, times 30%. So as you can see, 1 plus 0.3, and that is from the table in slide number. This slide I can put down here or in the reference for sure. So that one is reference table in slide number 4. Slide number 4. So from that we can get the volume that carry 23 times 1.3, so it will be 29.9 LCY. So it means that 23 bang cubic yard become 29.9. What is the capacity in terms of the volume of scraper? 30 cubic yard. So as you can see, it's good because it's less than 30 cubic yard. It means the scraper can carry this less than 30 cubic yard. So that okay for this dimension. Now talk about the load. You see, like number of people in the elevator. Now whether the load with those number of people meet the limit on the elevator. This is meet the limit of the scraper. So we can have another dimension, which is load in terms of weight. So as you have the weight equal to the volume times the density. So if we're talking about the bang cubic yard, then the density have to be bank density. So we have BCY, that is volume, time bank density. Or you can say loose cubic yard times loose density. Use the table. And let's see for this one with the clays and with the bank density, 3,000 pound per cubic feet. Or you get the loose cubic yard times the loose density, 2,310 pound per cubic feet. So that either way you will get the similar answer in there. So from here we can have 23 times 3,000, and again that is from slide number 4, and from that we get this number is 69,000 pounds. And as you can see, the limit is 65, so it's not good. Okay, so not good. So as you can see, that one is greater than, so it exceeds capacity, greater than 65,000 pounds. So what does that mean? Not okay. So when we estimate, we need to looking for many other dimensions. Otherwise, it's not be able to, the scraper not be able to carry this load. It's overloaded. How much overloaded you can be figured out, and you can see the percent of overload equal to 69,000 minus 65,000 capacity divided by 65,000. So it can be equal to about 6% overload. So what does that mean? Is the engineer load estimate correct? It's not okay, right? So bottom line, and you can see engineer. Not okay. So keep that in mind. When you do, we'll have to look at all the dimension, and for the material, the volume, the unit of measure, we need to specify whether it BCY, LCY, or CCY, and it to make the problem realistic and make you do a correct estimate. In the real life, when people concerned about how much I pay, should I pay by bank cubic yard, loose cubic yard, or compacted cubic yard? Normally, if the the project don't say anything, not specified explicitly whether bank cubic yard, loose cubic yard, or compacted cubic yard is applied, then this one is what people are going to pay, and that I call it pay unit based on what you put in my project. Then I pay that. I don't care how much you buy, how much you transport, but if you put in my project, that's what I pay, and that is compacted cubic yard.